I believe my screen is visible to all of you. Can anybody confirm that? Tehrim, can you confirm?
Yes, sir, it's visible.
Okay, great. All right. So let's move into this exciting new domain. I would not say it is a new domain, but it is quite exciting, right? So what we are understanding over here is understanding the system of for advanced vehicles. So definitely what we are doing right now, what we are like the world that we are living in right now is the world of advanced vehicle. You all have seen the vehicles have gotten so advanced at this particular point. You don't even have to literally start the vehicle and just think about your destination. No, the vehicle will do almost everything on its own. You have seen the live examples of Tesla autopilot, right? How it is happening. Tesla is able to take you from point A to point B without you interfering into its complete systems. So this is advanced vehicles, right? And not just that, let's just talk about, Tesla is being a very tech oriented company. Let's keep it aside. We can even talk about the companies that we have in India. They are also going fullest and getting all those techs in India and creating these tech here also, and availing it to us so that we can experience that as well. If I talk about Tata, if I talk about Mahindra, both of them are doing pretty well. If you see the recent comings for from the company called Mahindra, so they have taken out their recent two vehicles, which is BE6 and EV6 EV9E, if I'm not wrong about it. So that those vehicles are pretty much tech loaded. Those vehicles are actually working on the software. Those vehicles are working on the environment, right? So if you have got a chance to experience those, good. If you did not get a chance to experience that vehicle, please, I would recommend all of you who are here in the webinar today, in this session today, please try and take a look at the tech, or maybe go to YouTube, search a video on it, and check out the tech. How great it is, right? And how it is possible? It is possible through this software defined vehicles. So SDV stands for software defined vehicles. That means a vehicle which is defined by softwares, which is basically the vehicle, the functionality of vehicles is derived and dependent on the software. You have basically made a vehicle out of software, right? So this is we call as software defined vehicles, right? So let's start into it, let's jump towards it. So what is a software defined vehicle? Where where software plays a central role in the functionality, controls, perception, connectivity, and diagnostics. Just a second. Yeah. So this is basically the software defined vehicles is known for, where basically vehicles where like the software plays a central role in the functionality. Without the software, the vehicle is not able to move. The vehicle will not be able to run from one point to another point, and you would require the software. Or maybe if the vehicle does have the capability to go from point A to point B, still it would require the assistance of software to make the life, to make the whole entire journey easy, right? To make it more comfortable, to make it more safe. If I'll talk about one thing, which is the safety in advanced vehicles. So as of right now, all of you have heard about safety ratings, right? I am sorry for my writing. Okay, if anybody is having any issues with the with my writing, please let me know about it. But it's okay, right? So you must have talked about or maybe heard about this particular term, which is called safety rating. Now what is safety rating? Safety rating is basically a kind of a test which basically proves your vehicle how safe it is. And there are multiple bodies, regulatory bodies, which basically takes out this safety ratings, right? And all of those having different criterias. But there is one thing which is common in all of these bodies, which is now they basically give you safety stars, right, out of 5, and they will only give you 5 stars safety when you will have a software defined vehicle. That means your vehicle is defined by software and it is having functions like ADAS, okay, ABS, EBD, right? All of these functions, if they will be having, then only you will be able to, yes, yeah, so then only you will be able to get 5 stars of rating. So how it is happening? It is happening with the help of software defined vehicles, right? So yeah, this is what software is meant for the vehicles as today's point. It is not just one point. There are multiple things which we are basically using in today's world and today's time. At this point also, let's say I am driving a car, okay, every day I am going from point A to point B. I am using multiple things inside my vehicle which do require the software. Without that, I don't know if I'll be able to complete my journey. Let's say I am basically traveling with my vehicle every day, right? I'm driving for 30 minutes. Okay, just an example I'm giving you, right? In that 30 minutes, I definitely want to uplift my mood, and I will try to play a music into it, right? If we go back in 1980s and 1990s, at that point, if you remember, our vehicles used to have stereo players. Okay, those players were completely analog. That means you have to put a cassette into it, and that cassette had a reel inside it. I don't know if people uh, born after 2000s, or maybe people who are here who are born in 2004 2005. I don't know if you guys have seen the cassettes and all, but there used to be a thing called cassette, in which there used to be a reel, okay, and that reel used to hold a lot of songs or a lot of music, right? And you have to basically put that cassette into that stereo, and that cassette used to roll, and then you can listen up to the song, right? The whole entire process was too much, right? But nowadays, when I am doing a 30-minute drive every day, what I do, I just open my phone, turn on my Bluetooth, connect with the stereo system of my vehicle. Nowadays, it is not called stereo system, it is called as infotainment system. Infotainment system. Just to be clear about the terms, so, right? So, what is infotainment? I'll also tell you this. Uh, Let me just tell you this. This is info means information, and tainments comes from entertainment. So on that particular screen, now at this point, every car has multiple screens. So in that particular main screen, you will be getting information about the vehicle, as well as you will get your entertainment content. That means your you can pair up your phone through Android app, Android what do you say, Android Auto and Apple CarPlay, and you can also watch Netflix and all on that. Multiple things you can do, and also you can have the information about the vehicle on that particular panel, right? So what I do every day, I just take my phone, turn on Bluetooth, and connect it with my infotainment, and there we go. And I can play as many songs, as many music as I want. So this is again one of that thing which is possible because of the software, right? Because if there was no software, if there was no this kind of algorithm, then I would not be able to do all of these things with the vehicle, with my vehicle, right? So yeah, this is something which is very important in our life. As of now, we don't even realize it, but yes, it is important. Now we basically move on towards the uh, electric vehicles. So let's say, I don't know if some of you have, maybe some of you have got electric vehicles at home, and if not, also no issues. I'll just give you an example. Whenever you own an electric vehicle, right? In that case, what happens is you get an app, phone app with your vehicle, because the vehicle is connected, always connected with the servers, so that you will have the actual state of the vehicle. That means where the vehicle is exactly, that is through geofencing. Then you can also know the battery status of the vehicle. Then you can have multiple other things of the vehicle. You can basically track all of these things through the phone app. And how it is possible? It is possible with the help of, again, software, right? So software driven vehicles, these are basically cars that are that rely heavily on the software. Okay, from controlling the engine, let's say if we talk about the engine controlling, that is also happening through software. That is also happening through the algorithm. To let's say enabling autopilot mode, or maybe going to the diagnostic mode, or if you need software which is let's say, I would not say software, but if you want to have any kind of function that you want to basically find out in that particular infotainment screen, or maybe in your diagnosis area, then that will also be possible because of all of these things that you have gotten up with the help of software defined vehicles, like this whole term software defined vehicle, right? So if I'll just move here, now what you can see on your screen is, on the left side, if you can see, this is a particular app layout for a for an electric vehicle. So this is a Rivian RT1. Okay, so this is how the app would look like. It will first tell you how much range it is having. So right now it says 255 miles, right? It can also tell you, you can basically do multiple functions with it. You can basically roll up and roll down windows from here, sound alarm, open hood, then you drop tailgate. Tailgate is basically the what do you say, this particular gate, the boot. Okay, then open gear tunnel, driver side, open gear tunnel, passenger side. So multiple things you can do just with the help of the app. That means you don't even have to be physically present with the vehicle at that particular point. You can be in that radius also, right? And still you'll be able to do all of these functions. So this remote thing, this remote functionality of accessing your vehicle, accessing the functionality of the vehicle, is something which is directly which is basically proving that right now we are living in the future, right? And this is happening with the help of software defined vehicles, right? So what all things we can see with the app functions over here? We can see battery status, we can see range I have already explained you over here. We can see the speed also, navigation, diagnostics also you can do over here. So let's say you have given your vehicle to somebody. Let's say you have given your vehicle to your friend, and you have asked your friend to keep the vehicle in let's say 60 kilometer speed. Okay, under 60 kilometer per hour. Okay, so and your friend does not listens to you. At that point, what you can do, you can basically limit the speed as well, right? That too from a remote area. You should not be able to present inside the vehicle, or you should not be able to you don't even have to touch any system, any infotainment there. You just have to press a button on your app, and there it is. Everything will be done on its own. That is why electric vehicles are heavily relied on the software, and which is actually a good thing as well, because it is doing a lot with the help of software. Also it is creating the impact on us. It is making everything very very functional. Secondly, it is making everything too futuristic, right? So all of these things are there just for our sake, right? So let's basically we'll learn what SDVs basically do. Not just about this, but there are multiple other things where SDVs are involved. Okay, so I'll just show you that particular slide. So if you'll see, we have in total four sections. We have ADAS and safety systems, we have occupant experience, we have hardware, and we have telemetry. Okay, so and in those four systems, we've got subsystems as well. So all of these things, oh, I am sorry. Yeah. So all of these things are basically taken care through SDVs. So first we first come to ADAS and safety systems. In ADAS, we've got adaptive cruise control. For the people who don't know what is an adaptive cruise control, first of all I'll explain cruise control, and then I'll explain adaptive cruise control. So cruise control is basically when you are cruising on highway, when you are driving on highway, at that point you don't have to shift your gears multiple times. You are in the topmost gear and you have to continuously drive for, let's say, 50 kilometers, 70 kilometers, 100 kilometers. At that point, the vehicle gives you an option to basically put the vehicle into certain speed and in certain gear. So and vehicle will maintain that particular speed even if you are not pressing on the throttle, right? That is called cruise control. And now what is an adaptive cruise control? So adaptive cruise control is similar to cruise control but little smarter. That means we all live in India, right? So in this case, definitely there are people in India who have less of the road sense, right? And they can anyway cut your way at any point of time. Doesn't matter if you are on the street, doesn't matter if you are in a city, or you are on the highway. At that point, what happens? Let's say you are in cruise control, so you might have to rush and press the brakes as soon as possible. It can even cause problems as well. Let's say there was another vehicle which was tailgating you. What is tailgating? Tailgating is basically when a vehicle is right behind you. Okay, so in that case, and when you hit the brakes at that instant, what will happen? The vehicle which is coming from behind is going to bang into you, right? So that is an issue. Let's say if you still if there is no vehicle behind and you still press on the brakes, you might lose your traction as well. You might end up with a with some kind of an accident. So to basically get out of this situation, there is the invention of adaptive cruise control, which basically do what? It basically sends a radar signal in front of you and in front of the vehicle, and sense if there is any object. If there is an object, then it automatically lower down the speed, right? So it does that for you, so you don't have to worry about. Definitely you can override this particular thing and hit the brake instantly and all. That is already there, but this adaptive cruise control is specifically that for that particular thing. Now how it is happening? It is happening through algorithm. Okay, so definitely there will be an algorithm. That algorithm is using the if else statement. What is if else statement? If else condition. If there is a let's say object in front of the vehicle, so radar, what will radar do? Radar will send the signals, and the signals that are returning from after banging into the object, that those signals will be first interpreted and then send it to the algorithm, and algorithm will take the action to slow down the vehicle or not. In most of the cases it will slow down the vehicle automatically and keep you at safety. So this is one thing. Then we have airbags. Okay, then we have ABS. ABS is a very common thing. You already should know about it. Then we have traction control, automatic emergency braking. All of this actually this also comes under adaptive cruise control as well. So all of these things are happening through software, right? So this is just one system. We still have other three systems as well. Now let's talk about the occupant experience. Here we have infotainment that just we have talked about, right? We have tracking is happening through GPS and GNSS. Okay, GPS, you already know, global positioning system, right? So it is happening with that. Then we have climate control inside the vehicle. So you like there are vehicles which basically comes with dual zone climate control or maybe multiple zone climate control. Basically you can, or there are vehicles which comes with automatic AC, automatic air conditioner. So that is also comes under climate control, right? So it basically sense how much the temperature is going inside the cabin and create the climate, like take the AC to that particular, it will set the AC to that particular setting, where it will basically keep the whole environment of the cabin around 20 degrees, 25 degrees, whatever you will set to it. So that comes under climate control. Then we have acoustic management. So management is basically the speakers, the sound, the NVH level, the harshness of the road, and a lot of other things. That also comes under this SDV. Then we have telemetry over here. Telemetry is OTA, cloud communication, then V2X. So OTA is over the air updates for the people who are owning electric vehicles. Let's say if you are owning an Ola or Ather, or maybe Tata Tiago or MG Comet or any other vehicle, you must have gotten at some point of time, you must have gotten an update for that particular software or maybe firmware update, right? It's as simple as you update your phone, update your laptop, right? So you update your Windows from Windows 10 to, you have updated to Windows 11. For in your phone from iOS 17, you have updated to iOS 18, right? It's similar to that. So just like your phone and laptop gets over the air updates, you don't have to take it to the service center or maybe to a place where they will update it manually, but you just have to connect with the internet and the update is already there. You just have to download and install it. Similarly, you have to do it with the electric vehicles. You just have to connect it with the internet connection and the update will be there. You just have to download it and install it. That's it, right? Then we have cloud function over here. Cloud function is basically so that your vehicle should always be connected with the server, so that the information can be passed from the vehicle and to the vehicle, right? So all the app notifications that you are getting and the information of on the app that you're getting is actually getting through cloud. The app is not directly connected with the vehicle. It is connected with the vehicle when you are inside the vehicle or maybe around the vehicle. But let's say vehicle is here and you are here at this point, so the distance is quite a lot, right? At this point, how you will be connecting it with the vehicle? You'll be connecting with the vehicle through cloud, because vehicle is connected to the cloud and you are also connected to the cloud. So indirectly you are connected to the vehicle, right? So that is how you can do, you can operate multiple functions through cloud. Then we've got communication over here. In communication, we have V2V, vehicle to vehicle, then V2M, then V2P, vehicle to person, then V2I, vehicle to infrastructure, then V2X stands for vehicle to everything. So basically, when vehicle is trying and establishing a communication with everything, infrastructure, buildings, or vehicle to vehicle, or the signals or any other cloud is there out there. So when vehicle is communicating with everything, that is known as communications and V2X, right? So this is about our third system. Then we have got fourth system, which is hardware. So the hardwares are systems on chip. That means our ECUs. Okay, you all should know that every vehicle has multiple ECUs, starting from 50 to maybe ending to 150 ECUs as well, right? So all of these ECUs are also known as system on chips, ECUs, domain controllers, uh, then high performance computers, right? Somebody asked a question. Screen is not visible. I think it is visible now. Okay, I'll just uh, I'll just move ahead. So yeah, this is basically about a little bit about the SDVs. Now let's go into a more deeper manner where we'll understand more of the things about SDV in the EV sector also. Okay, this pretty much what we have just talked about is not specific to electric vehicle, but it is for general automotive. These things will be there in electric vehicles and in IC engine vehicles as well. You might see these things everywhere. Okay. Now, when we talk about, so this is basically when we are talking about a little bit in context of electric vehicles, where we have controls, perception. Okay, so control, what it means basically, software governed codes vehicle functional like accelerating, braking, steering, and battery management. So what is happening? You all know that Tesla is one of the pioneers for autopilot mode, right, where basically the vehicle can run on its own. So how it will run on its own? You basically, the vehicle has to take a charge and accelerate itself, brake itself. Also it should able to steer in the directed way, maybe to the right side, maybe to the left side, maybe slightly left, maybe slightly right, right? So all of these things basically comes under control, right? And the software would should be able to do that. So, and that again is happening with the help of, again, codes and algorithms, right? In EVs, the battery management system, BMS, motor control unit, and power electronics rely on software for real time decisions. So, when we are talking about BMS, there are multiple algorithms which are going inside the BMS just to find out SOC of the battery, SOH of the battery, state of energy, and multiple other things, temperature, and then taking care of the thermal signatures of the battery, and finding out the range every 2 seconds. And finding out the consumption of the battery, how to balance the cells which are basically there. Let's say if you are charging the battery pack at a very higher rate, okay, like with the very high power output, so what will happen to the battery, taking care of the battery in multiple ways. So all of these things are there inside of BMS, which basically requires a lot of algorithm, which basically requires coding and requires microcontrollers inside. Again, this all comes under software part. Okay, similarly with MCUs, which is motor controller unit, right? As we need for motor controllers, let's say what kind of motor you are using. Either you are using induction motor or maybe a DC motor. In DC also, is it a BLDC or a normal DC? Then we've got what kind of control method you are using. Is it DTC? What do you say? Uh, I forgot about that control method. Um okay, when I'll remember that the name of that, I'll basically tell you about it. So there are two control methods, okay, through which basically you operate the motors. Okay, then coming to the control part over here, regenerative braking. Intensity is dramatically controlled by software based on driving conditions. So this happens with the level 3 ADAS. So it this also comes under ADAS part sometimes, and in most of the times it comes with almost every electric vehicle out there, because regenerative braking is only possible with electric vehicles, right? It is not possible with IC engine vehicles, right? So in that the braking intensity changes and controlled by software on the basis of your driving conditions. If you are hard braking, if you are recklessly braking, or maybe you are braking in a not so good manner, in that way what will happen, either your intensity will drop down, or maybe it will increase up a bit as well, right? That again depends on the driving behavior and that you are following. If you are hard braking it, so what is happening when you are hard braking? So you are trying to reach to the object in front of you as soon as possible, and you're trying to stop at just at this point. Let's say this is the object and you are coming from here, and you're trying to stop just right at this point. So what will happen if you want to stop at this point? You have to press the brake. There can be two ways. Either you can start braking from this point and ends up over here, or you can start braking from this point and ends up here. In both of the cases you will stop at this point, but in this part what will happen, the braking time is reduced, right? You have definitely press the brakes for a longer time, but the time like you have pressed the brake with a longer force, with a better force, but time has been reduced. And if the time is reduced, the energy generation over here is also reduced. But if you start braking at this point and brake still here, the time is exceeded, right? So that will create, let's say, I'm not saying it will create a lot more of a difference, but it will still create at least 1 or 2% of difference, which is again good enough for you to have a better mileage, or to have a better range, right? So this is about control. Then we go into perception. What it means, the ability of the vehicle to sense and understand its environment using sensors and software. So basically, perception, in perception, what comes in, or ADAS basically comes in when we are talking about radars, when we are talking about lidar systems, when we are talking about cameras, 3D cameras and all. So basically, when you are mapping the environment around you with the help of equipments like radars, lidars, and cameras, that is known as perception. You are making sure the vehicle is communicating with the environment, and vehicle is trying to know the environment which is around you. You can just take a like you can I will give you an example to make you understand. Let's say a small baby tries to learn the environment around him when he first starts walks in, right? So when he's starting to walk, or maybe starting to crawl, so he tries to touch everything which is near to him, right? That is his level of perception, that is his mode of perception. But our vehicle, in terms of vehicles, the vehicles could not go and bang around in every object out there, right? That would be a problem. So in that case, what happens, we have to give the vehicle its eyes, its nose, its ears to sense. And that is how we also sense, right? We see, we smell, we hear, right? This is our perception. Similarly, we have to give this perception to the vehicle as well, and this perception is given to the vehicle through these things: cameras, lidar, radar, ultrasonic sensors, right? So that the vehicle will be able to map the environment around it, and then take the decisions. So there's decisions like lane keeping, pedestrian detection, and adaptive cruise control are enabled by perception softwares. Okay, so all of these things, there are just only three or to four things listed over here, but there are multiple other things as well, which basically can be done with this perceptions, right? So again, and how basically we can integrate all of this with the help of a software, right? So each of the slide I will be talking about. In the end of the in the end, I will be concluding it towards the software, because again, if it will not be like that, there will be, we will not be able to function through a, very we will not be able to get out of that particular, I would say, 90s era, right? So I'll come to that point also, like the analog era. I'll come to that particular point as well. Okay, then the next part over here is, okay, there are questions. What are the most critical software competencies engineers must build to stay relevant in SDV ecosystem? Great question, Satyam. We will answer it once we are done with the session. Okay. Yeah. So with the connectivity, basically what it means, it basically enables communication between vehicle, cloud, infrastructure, and mobile devices, right? Everything I have just already covered in the previous slide, right? And in electric vehicles, it enables remote monitoring that we have just seen in the first or second slide. Over the air updates, I've already talked about. Charging station location, which is another new thing. And this is not just for the vehicle, this is also for the charging stations, charging infrastructures, and the apps that are coming with the charging infrastructure. So this also works with that. And vehicle to grid interactions. So when you have to interact with the grid as well. So when you have to basically give energy back to the grid from the vehicle. So with that also you would require connectivity, and that is happening with the help of softwares, right? Then in diagnostics, what it means is basically continuous health monitoring of the vehicle component using embedded software. Okay, so it will basically monitor the health of the components, let's say battery components, or motor components, or controller components, or any other components which are used in the whole systems, will be diagnosed on a regular basis, right? So that is again comes handy for you, because you will get to know things on a prior basis as well, so that you don't have to wait for your vehicle to break down, and then you go to the mechanic, or maybe to the service center, and then get your vehicle fixed. No, not required. You can run a diagnostics on your own. You can find out what is the issue. Okay, you can find out the DTC codes. You can find out what does that code mean. Okay, and then you can definitely, if the problem is big, you can go to a service center. Or if the problem is not big, in most of the in many of the times, you can also do some little things at your own pace as well. Like if I'll give you an example of the vehicles that comes into BS6 edition, the diesel vehicles that I'm talking about, right? So these diesel engines which are below 1.5 liter capacity, so below 1500 cc engines, diesel engines, they don't have DPF, right? And all the engines which are bigger than 1.5 liter are having DPF. So what happens, they have three-stage catalytic converter inside it, and all the like basically they regenerate the DPF inside it. So the catalytic converters into those vehicles basically clogs up after every 2 months or maybe 3 months or maybe 4 months. And what you have to do, you have to basically go to the settings of the vehicle, go to the diagnostics, and then you have to refill or regenerate the DPF that you do, right? And you just have to leave the vehicle on its own. Vehicle will do everything on its own. It will take up the engine RPMs about 2000 to 2500, sorry. It will take up the engine RPM, so from 2000 to 2500. You have to keep the AC on, you have to keep the windows down, and multiple other things you have to do. And by that you have basically performed a particular task for your own vehicle, and with the help of the vehicle itself. So that is also happening with the software, right? So the diagnostics you can perform with that. So this is making your life easier, right? It's not about you have to always go to the service center or the mechanic for every small or big thing, right? There are things that you can also take care of. So moving on, now we are basically coming to the evolution era. So basically the evolution from mechanical to software defined vehicles. The first, if we go way back in 1980s or pre-1980s era, which is called mechanical era. Okay, in that the key traits were the entire system was mechanical and completely analog design. Okay, like examples, if I'll give you, there are carburetors for air fuel mixing. Even we had carburetors, let's say 7-8 years back. Till now, we had carbureted engines also. So they are coming from that time, like 1970s, 1960s. And still we were using carburetors. Again, one of the greatest invention in entire automotive industry of inventing a carburetor. There no sensors, manual steering. There used to be no you used to have to put a lot of effort just to steer the vehicle right and left. And let's say if you at some point your tire is flattened out, then you have to do a lot of efforts just to turn the steering around, because there used to be no hydraulic steering or electro hydraulic steering or complete electric or power steering that we call it. Okay, no sensors, no ECU, nothing, right? No data processing, nothing like that. So it was completely a mechanical machine. It used to be in 1980s, in 1970s, in 1960s, right? Then when we move towards the new, a little ahead, then comes the electromechanical era, 1980s to 1990s. Okay, introduction to electric actuators and a little bit of sensors, where you basically got to know a little bit about, what do we say, central locking. There used to be parking sensors in some of the vehicle, very high-end vehicles I'm talking about, but there used to be these things. There used to be power windows and one touch down, one touch up windows. Everything used to be there, right? In 1980s to 1990s era, there are multiple vehicles. There is a vehicle called Toyota Crown. Then there is a what I forgot about that particular. I forgot about the name of that vehicle. Dorian. The name of the vehicle is Dorian. So that was the first vehicle that came up with the sunroof, right? So again, this is actuated. This is with the help of sensors. All of these things were happening, right? So that was the electromechanical era. Then we move towards the next era, which is electronic era. If we see, which is from 1990s to 2010, where we finally have get to see ECUs, right? If somebody who is 1990s born and they used to have a vehicle at their home in 1990s, or let's say 1998, 1999, at that point in India we used to have Hindustan Motors, Padmini, and then we used to have Maruti Suzuki 800 as well. So at any point of time, if you must have opened up the hood, you must have seen it was just the engine and no wirings and nothing all, just the engine and hoses. Hoses are the pipes, right? Just that. But after that, after let's say 7 8 years down the line, there were engines which were completely packed with wires and stuff. So those that era was electronic era, where basically engines were taken care with the help of ECUs and ECM models, VCUs, ECUs, TCUs, right? All of these things have added into that. Okay, then we come to the software defined era, which basically started with from 2010s and it is still going on. With that, we whatever we have just talked about in the previous slides, everything covers in the software defined era, right? So yeah, this is the evolution from mechanical to software defined vehicles. Moving on, I'll have to wrap this up a little quicker so that sir will also have time to explain his part. So then we have, again, I have already explained about ECU. So each car will have at least 150 to 150 ECU units, okay, which handles braking, engine controls, airbags, motor controls, batteries, and all multiple things, right? So all of these things happens with the help of ECUs. Then the key software domains in vehicle, like what are the software domains are there in the particular vehicle, which is basically done through which basically comes under SDV. Is first is powertrain control, where it controls the whole battery pack, it controls the whole motor and the power figures of the vehicle, right? It also controls the vehicle dynamics as well. So that comes under this part. Then we have infotainment. Again, we have already talked about infotainment, right? We have ADAS also, that also comes under software area. BMS, right? Then the sensor that we require, like few of the sensor which we require is basically cameras, right? We all, like at this point, there will be, I don't think there will be any vehicle which is coming from factory without any camera, right? At least one camera is there in almost every vehicle. Reverse parking camera, we can say. And there are vehicles which are having 6 camera setup, or maybe 4 camera setup as well. You are also getting bird eye view in your infotainment system with the help of 4 camera setup or 6 camera setup, right? So that you can find out if there is any obstruction or any stone or any different terrain right beneath your right under your vehicle, right? So yeah, that happens. There is I think if I'll give you an example in Defender. So Defender gives you this particular option, and then Rivian was the first company coming up with the this particular feature in electric vehicles. Then Ford F-150 in both in electric segment and in both IC engine segment, both it gives you that. So there are multiple companies which are giving you all of these features with the help of cameras, right? Then we have radars. You all know why do we use radars, right? Then moving on, we've got lidars as well, right? Lidars we use for better mapping of the your environment. So basically, with the help of lidar, you can map and detect the shape, edge, and depth. With radar, detecting shape and detecting edge was still possible, but again, it was not that precise. But getting the depth was not possible. But with lidars, you can basically get the depth of it, depth of the object, and shape, size, edges, how far it is, how tall it is, everything. All of these things you can get through lidar. So that is why it is considered or maybe used for 3D environment mapping. So basically, you are actually mapping everything in 3D as you are seeing through it through your eyes, but definitely with less colors. And then we have another very important unit, which is IMU, which is inertial measurement unit. So what is IMU? So IMU basically tracks acceleration, angular rate, and orientation, essential for vehicle motion tracking when GPS or vision is unreliable. Used for navigation, dead reckoning, stability, and stability control. So it used to basically, it was developed and designed for spacecrafts and all. But nowadays, you get IMU in electric vehicles and almost every vehicle which is connected to the system, right? So on the left side, this is the part which used to use in the spacecraft, and on the right side, this is the board which basically use it in the vehicles nowadays. So we've got multiple components over here. We've got mag, we've got MCU, accelerometer, gyrometer. So mag stands for magnetometer. It basically measures the magnetic field, magnetic field strength and direction around the device, okay, and helps you determine the vehicle, like where the vehicle is heading. It will also tell you the orientation of the vehicle, right? Then we have accelerometer, which will tell you how fast the vehicle is moving. Then we have gyrometer, right, which will basically find keep the vehicle intact in that same orientation, right? So all of these things are there, which is basically one of the very important thing when you are highly relied on softwares and working with autopilot things or maybe adaptive cruise control and all. These things are coming very handy, right? Then moving on. Now we are going towards a little bit of software development cycle. So until now, whatever we have seen, whatever we have learned is about what we can do with the software defined vehicles, what have been done, okay, and we have also seen a little bit of applications and examples in the in the real life conditions, right? So these all things we have seen up till now. Now how basically it starts, how basically the development of this particular things happens. So the very first thing, the very first stage is the MATLAB model based designing using Simulink, right? So what happens, basically first of all you have to design and simulate control system before coding. You have to do the model based design, okay, before going into codes, okay, because you cannot code without having a clear objective in your mind, right? You would require to put calculations into it, solve equation into the codes. But how will you get the equations if you don't even know the constants or maybe the variables, right? So you should you have to basically first make the model based model like this model based programming with the help of Simulink, and then basically you can first you validate these and then you code it. We've got the advantages over here is early validation of system behavior, right? So basically you get the validation of the system if the system works or not. Then we have rapid prototyping and iterations. With the help of model based designing, you can basically do the rapid prototyping, and if there will be any iterations, you can do that as well. Visual and logic based design also is possible in this. So example, if we see designing a battery BMS, battery management system, or motor controller control logic directly in Simulink. So let's say if you are creating a battery pack for your vehicle, let's say you want to design a vehicle and you have to select a battery pack and you don't know what to do with it, how to do with it, right? So you have to basically simulate all the, you have to put all the cells in series and parallel order into the Simulink, and then find out the complete voltage and current characteristics of the vehicle, and how for how long it is running with different loads. Let's say if you are taking up 10 amps per hour, okay, so for how long the battery is sustaining itself, or let's say if you are taking a 15 amps per hour, and so on, you can increase the load, decrease the load, and that is how you basically design a battery pack or BMS for your system, right? And that you can basically, you cannot do it with the help of code, or maybe you cannot do it with the physical actual equipments, right? You have to first simulate that. And where will you do it? You'll do it in the Simulink MATLAB. So the very first thing is you have to validate it through Simulink. Then we go towards the next things, which are MIL, SIL, and HIL. So MIL, what is MIL, what is SIL, and what is HIL? So with MIL, which is known as model in the loop, test control algorithms as model. That means whatever the algorithms you have basically made, it will be controlling the algorithms as models. No actual code or hardware involved. I've already explained that, right? Detect logical or mathematical errors early. If there are any logical errors, if there are calculation errors, if there are, any other kind of errors, so in model in the loop, in this phase, those will be detected and you can basically rectify those. Okay. Simulating charging logic or torque control under variable loads is one of the example of this. Okay. Then we have software in the loop, SIL, which is known as SIL. Run the generated code in a simulated environment. Check if the model generated code behaves like the design. So first, what you have to do is, first you have to make the model. Okay, then keep the model in the loop to find out any errors, and if there are errors, you have to rectify those errors. Then later on, you have to run the code, like you have to generate a code first and run in the simulated environment, and check if this code is acting or behaving just like it was acting in the Simulink model, right? Example over here, verifying C codes generated from a motor control model. It is just an example, right? So this is your MIL or MIL, this is your SIL. Now we go towards HIL, which is hardware in loop. Okay, combine real ECUs or embedded controllers with a real-time simulator, emulates physical systems, example battery pack, vehicle dynamics, okay, and used before the real world deployment. So basically hardware in the loop is the last or the final thing which basically comes in the action, right? So this is basically the whole development life cycle of a software which is being used for the vehicle. So this is all about software defined vehicles, what we basically learn about software defined vehicles and how do we start towards it. So if I'll just conclude that, what do you need? You first of all, you need a path, you need a objective. Second, you should know how to do model based designing. Third, you should know these three things, mill, sill, and hill. And there you go. If you are aware of all these things, if you are if you have mastered all of these things, then the possibilities are endless, right? So yes, this was pretty much it for the SDV part. At this point, I would like to invite Ayush sir for taking over the session for the next part of it.
Yeah, hi Rahul. I'm just thinking that how much time do we have for the next part? I mean, how long the session will be and how long will be the question answers? Just trying to think
Uh,
on that.
I think we still have around 30 minutes.
30 minutes, okay. Okay. ठीक है. So guys, I'll try to cover the part of the ADAS and AUTOSAR, right? I hope everyone is comfortable with English as the medium of instruction here. Just give me a second. Let me share my screen and I will start delivering my part. It's quite a technical session, isn't it? I mean, the topics Rahul has covered, they're quite technical in nature, and I'll try to cover the same domain, but more in terms of the AUTOSAR and ADAS. I don't have any sort of slides or presentation ready with me, to be very honest. मैं directly blank screen में लिख के समझाऊंगा. I'll give you the example of a car, a basic car, and then I will try to explain you how you can develop your AUTOSAR system and the ADAS system on it, and how you can move from the current situation to work into the ADAS and AUTOSAR. That is very important. See, we know कि हमें क्या क्या करने का मन है ADAS AUTOSAR में. That is something we can explain. That in ADAS you have the cruise control, you have the lane detection, you have the safety system. But the main question is कि सर मेरा जो अभी current level है, the current level I have right now, how do I move to ADAS and AUTOSAR from it? Whatever you are explaining me right now that we should do this, we should do that, how would I be implementing these things? That's the most important question here. So I will try to explain it in that way so that each one of you, based on your current expertise level, will be able to understand how do I move from this position to the ADAS and AUTOSAR expertise. Okay, this is what I'm trying to explain in this session. So अगर notes बनाने हैं इसके तो बना लो, and this is going to be quite what do you say, intensive session, to be very honest. ठीक है, so just confirm if you all can see my screen. So let's start with MATLAB, because MATLAB is something each one of us is able to work on. So we have, in terms of the software, we have MATLAB. And just let me know, guys, if my writing is too bad, okay? And in terms of the hardware, we have the embedded. Just a second. Yes. We have, or maybe don't say embedded, let's say we have the knowledge of ARM Cortex. Because right now DIYguru is moving into the ARM Cortex entirely, okay? MATLAB is something many of you are already aware of. ARM Cortex is something very few of you are aware of. Maybe I assume you're gradually moving into the ARM Cortex system now. To be good enough in MATLAB, maybe you started with the what you say, the basics of MATLAB. From basics of MATLAB, you're moving to Simulink. In the Simulink, you are doing the design of the architecture, the modeling, and the simulation. इतना सबको clear हो जाना चाहिए. It's not something, it's not rocket science. इतना simple है, right? In MATLAB, we have Simulink, design, modeling, simulation. Other than Simulink, we have toolboxes like QSS. We have like the advisor. We have like Simscape, right? In QSS advisor, Simscape also, we have designing, modeling, simulation. This is, I assume, my students will be able to work on. If you have done the advanced modeling course, I assume इतना हमें पता है. Okay, let's move on to the ARM Cortex now. Now for the ARM Cortex thing, we are having the basic knowledge of embedded C. We have the basic knowledge of STM32. We know how to connect the sensors. अगर नहीं पता, it's fine. Sooner or later, you'll come to know about this. We know how to basically program my sensors. Okay. This is very important. If you don't know how to program your sensors, you will not be able to implement ADAS or AUTOSAR. ये सिर्फ एक concept रह जाएगा. You won't be able to work on it. And at the same time, you should be able to perform data acquisition. Now, this is one of the most important thing, data acquisition. Now, what is data acquisition? What exactly it says? Data lena. I'm collecting the data. Okay. I should know how do I collect the data from the sensors. The whole AUTOSAR and ADAS can be summarized into data collection, data processing, data communication. As an engineer, whether you're mechanical or electrical doesn't matter. If you're a mechanical engineer, you would be working on different kind of data. You would be working on the data from the motor controller, from the regenerative braking. As an electrical engineer, you would be working the data from the charging system or the battery system. Doesn't matter. Data can be anything. हमें ये नहीं समझना कि what sort of data I'm trying to collect. What I need to understand is how do I perform data acquisition? How do I take data from my sensors? How do I communicate between the controllers? And how do I perform the MATLAB-based simulation and analysis? This is my starting point, guys, okay? If you want to go into the ADAS AUTOSAR, this is your starting point. So now I assume that you are good with the simulations. Now you are good with the basic hardware programming. बहुत खराब राइटिंग है गाइस, अगर नहीं समझ में आ रहा तो बता देना, ठीक है? But I'm explaining every word, so it should be okay. This is your starting point, okay? Now let's start with the simulation part. Why do we exactly use the simulation? You'll be like कि ADAS को तो मैं directly system पे use करता हूँ. I have my own car. I use my ADAS there. Why do I actually need the simulations? You need the simulations to build your own scenarios, right? If I take the basic example of a car, let's say, if I take the basic example of a car vehicle, okay, this is my four-wheeler typical car, and I want to implement the ADAS on it, okay? Now to implement the ADAS, what exactly ADAS is saying? Advanced Driver Assistance System, right? So I want to develop a system which is supporting my advanced driving skills. I should be able to look at the surrounding view. This is known as the surrounding view, SV. I should be able to look at some sort of blind spot alerts. So we can say blind spot alerts. I should be able to perform some basic traffic sign recognition. Let's say traffic sign recognition. I should be able to perform operations like human detection, collision avoidance, emergency braking. I should be able to perform adaptive cruise control. I'll explain all these things, not a big deal. But mainly ये important नहीं है that how do you understand this technology. For me, it's more important how do you develop this technology. Okay, so we'll go in that part. Okay, this is the alert, but the main blind spot is somewhere like this. So this is my primary blind spot alert. And I should be able to perform some parking assist. Okay. This is how I want to make my car smarter. Now you will be like, okay, I want to cover my surroundings. I want to cover my blind spot. I want to cover my alerts. I want to perform adaptive cruise control. I want to perform I want to avoid any collision. I want to apply some emergency braking, some traffic sign recognition, lane detection warning, all those things. What is the first step? The first step is where and which software I need, where and which sensor I need to use in my system. If you want to implement all these properties, adaptive cruise control, the avoidance of the collision, emergency braking, right? Or if you want to implement the traffic sign recognition, you need to use specifically the LiDAR-based radar, that is the LiDAR. We need to use the radar as a sensor. How radar works, that's not important right now. The first thing is I need to know how to work on the LiDAR-based sensors, okay? For the surrounding view, I can use the cameras. From the cameras, I can perform some traffic light detection also. I can perform the surrounding view. I can look at the back of my vehicle using the parking assist. So all this is coming from my camera system. So one is my LiDAR. Second is my camera. I might need another type of sensor only to see if there is any collision. I generally apply it at the sides of my vehicle. This is used through the ultrasound sensors. What do I have by now? This is pure engineering I'm talking about, okay? I'm actually telling you how to become an ADAS engineer right now. इसको ध्यान से सुनना हो. What do I need to start with? At least to start with, what do I need? I need to know how to use a lidar. I need to know how to use a camera. I need to know how to use an ultrasound sensor. If you know how to use these three sensors, you are ready to implement your own ADAS operation. Now you will be like कि ठीक है, पता चल गया lidar camera ultrasound पे काम करता है. But the question is, how do I do it? And there are two ways. Either you do it through the software or you do it through the hardware. You cannot say that I can either choose software or hardware. You have to do both of them. Once you cover the software, then you move on to the hardware. You cannot go to the hardware directly before software. You cannot just do software and leave hardware. The process has to be followed. The software exactly is the MATLAB. Now in MATLAB, what you can do or what you will do once your MATLAB course is complete, guys, once you start the ADAS course, I'll tell you what exactly you'll do. You will take the data from the lidar, from the camera and from the ultrasound, and you will feed it in your MATLAB architecture. And you will make these ADAS algorithm blocks, which will take the data and will perform the ADAS operations. There are some building blocks in MATLAB which you can configure, or you can program your own block. It might be a bit difficult, but we can use some standalone blocks and configure them because MATLAB provides us these kind of blocks. And you can take the simulated or any random data from the camera, ultrasound and lidar to perform the ADAS operation. So what is the use of MATLAB? MATLAB provided me these blocks already. MATLAB said कि ठीक है, you don't perform basic operations, you optimize your system, you make some advanced system, you connect the lidar with the ultrasound with the cameras, and you see how your car should perform. And before we apply to an actual car, we use the simulations. That's why we use the MATLAB. So what do we need to do? Once we are good with the MATLAB, we need to go from the MATLAB simulation to the ADAS implementation using MATLAB. This is one of the main steps. Okay, perfect. So where is the hardware? अब हार्डवेयर की रिक्वायरमेंट क्या है? We have already got the data. हमने इंटरनेट से उठा लिया. Let's say we have the data from the internet, lidar, camera, ultrasound. What's the use of hardware? Now, the use of hardware will come to those who are good in embedded systems. Those who are good in embedded systems, they will come to me and say, "Sir, I'm good with embedded system. You provide me an ultrasound sensor, you provide me a camera, and you provide me a small lidar, and I will interface them through the ARM Cortex. And I will take the real hardware data, and this real hardware data I will send to my MATLAB." It's very simple. Sending real-time data to MATLAB is not at all difficult. You all will do it. But you need to be very good with ARM Cortex and MATLAB both, because ADAS is an application. Okay, ADAS is not a technology, it's an application. It involves exactly, Rahul sir said that it involves the HIL and the SIL. It involves the hardware and the software. So those who are now into the embedded system course will now go to the advanced embedded system. And when they are done with the advanced embedded system course, then they will be able to interface these three sensors, and they will combine the real data to the ADAS. Now you have the software simulation, which you have already done. This is no longer required. You can directly use the hardware data into the ADAS system model, the ADAS architectural model, which you have developed with MATLAB. And you combine the software with the hardware. अगर इतना कर लिया बहुत है. No one expects you to do this much also. You will be like, okay, how do I implement it in my car? You can use the Simulink coder to convert this software system into the hardware compatible code, and you can burn this code into your ARM Cortex. And then you don't need a MATLAB software at all. Everything will be implemented in your ARM only. But this is very difficult. We won't talk about this. This software coder vagara is at the industry level. What you need as engineers as of now, if you want to go into ADAS, you need to be able to program your sensors into the ARM. That is the hardware part. You need to be so good in MATLAB that you're able to develop this ADAS systems. And very soon ADAS is going to start. Hardly a month or 2 months later, your ADAS course will start once you're done with this MATLAB modeling and embedded thing entirely. This is the precise, the exact point-by-point way. How do you implement the ADAS system as a student right now, as a part of this ongoing training or as a part of whatever you're doing into the EV systems, right? And you just need some level of sensor interfacing, ARM Cortex programming, advanced MATLAB knowledge. Through MATLAB, we do the simulation, and finally we will convert it to the hardware data to combine your software with the hardware. But let's move on to the AUTOSAR now. Now, AUTOSAR is something which is not for everyone. I'll be very honest. AUTOSAR is something your company will expect when you have enough working experience, because AUTOSAR is a slightly advanced topic. Ab AUTOSAR kar kya raha hai? I'll tell you how AUTOSAR and ADAS are connected, okay? I'll tell you how you will implement AUTOSAR also, don't worry, but it might not be required by all of you as of now. Now, for example, you have implemented this software of ADAS. Okay, it's a very interesting story, guys. I'll show you exactly how ADAS and AUTOSAR are integrated to each other. For example, you have developed this ADAS software. Okay. With this ADAS software, you have some hardware also, some sensors. You have the microcontroller also, the ARM Cortex. Now, for example, you have implemented this ADAS entirely on a car model. The same car which we tried last time, okay? The smaller wheels this time. And let's say you have this ADAS to perform the avoidance of the, the pedestrian, where you do not want to collide with the pedestrians. You have used a LiDAR. You have used basic ultrasonic sensor for the alerts, and you have used cameras for the surroundings. You integrated all the hardware data through the embedded. You're sending it to the ADAS MATLAB, and you're running in your vehicle. अभी के लिए ये मान लेते हैं आपने vehicle के अंदर कंप्यूटर रखा हुआ है. अभी के लिए let's assume that your system is there. आपके हाथ में लैपटॉप है and all the data is getting into the MATLAB. Okay, because this is possible. I won't say कि आपने ADAS सॉफ्टवेयर कोडर के थ्रू पूरा व्हीकल में इंस्टॉल कर दिया. दैट इज वेरी डिफिकल्ट. इवन माय इंजीनियर विल नॉट बी एबल टू डू इट एज ऑफ नाउ. वी आर स्टिल वर्किंग ऑन दैट. सो अभी के लिए लेट्स अज्यूम दैट यू हैव अ लैपटॉप इनसाइड योर कार. यू हैव द बेसिक सेंसर्स. आपने कार के पास सेंसर्स लगा दिए. यू हैव कनेक्टेड थ्रू आर्म कॉर्टेक्स, एंड थ्रू दैट यू आर गेटिंग द डेटा इनटू योर मैटलैब लैपटॉप. इतना तो हम सब कर सकते हैं फॉर श्योर. आफ्टर दिस प्रोग्राम कोर्सेज विल एंड, विल डू इट. नाउ वेयर एग्जैक्टली इज द AUTOSAR here? The solution which I am proposing to you right now at the R&D level is a very good solution, but at the industry level it's a very bad solution. मैं बहुत 5 मिनट में इसको wrap up कर दूंगा. बहुत लंबा सेशन हो गया वैसे. The AUTOSAR says that you should not combine the whole solution inside a single solution. The AUTOSAR will say there should be a different layer for the software. There should be a different layer for the hardware. There should be a different layer for my microcontrollers. If there is a car coming from behind, the sensors will take the data from the surrounding car. This is my hardware layer. This data will be transmitted to my, microcontroller through basic analysis, which we call at basic software, BSW. For example, you have the basic battery software, you have the basic braking software, you have the basic what you say, the charging control software, all these basic standard softwares are there. From the hardware, it is connecting to my basic software. From the basic software, it is going to my electronic control unit of ADAS, and it will tell if there is a car approaching and I should be taking possible actions here, right? And then this ECU will communicate with my hardware through this basic software to apply brakes. अभी भी हम वही काम कर रहे हैं. We are exactly doing the same thing, but AUTOSAR ने क्या बोला? AUTOSAR said that let's have different layer for different operations inside my vehicle. That is why AUTOSAR is basically the system software architecture of my vehicle. And यही काम है AUTOSAR का. But if I go too much inside or within this domain of AUTOSAR, ज़्यादा हो जाएगा students के लिए. At the end of the webinar, just make sure that if you are working with me, just make sure by the time you end the program, we all should be able to implement this. If we are all able to implement this, we are already at the top 0.5% level of expertise, where we have combined the software in loop, we have combined the hardware in loop, and we have developed the ADAS algorithms, the ADAS operations. That is why embedded is so important. That is why we are constantly saying, let's do embedded ARM Cortex. Because without that, you will never be able to collect any real data. फिर हम सिर्फ ADAS को पढ़ते रह जाएंगे लाइफ में. That ADAS ये करता है, ADAS वो करता है, cruise control. What exactly is cruise control? When you are going on a highway, on an expressway, सामने से एक vehicle ने speed अचानक से कम कर ली, you are not able to apply the brakes. The vehicle should be able to apply the brakes automatically. If you are able to perform the sensor integration, if you are able to perform the integration with the brake control, you can easily make these applications. ये नहीं कह रहा industry level पे बना लेंगे, but you will be able to create the prototype of these ADAS applications for sure. But if you're not good with the ARM Cortex or with the sensor interfacing, or you're not good with the MATLAB, you will only be able to do ADAS at the theoretical level. That is why we cannot go to ADAS till we complete the embedded part. हाँ, अगर सिर्फ सॉफ्टवेयर पे सीख के रहना है, then it's a different thing. Then you don't need the ARM Cortex or sensors. But if you really want to implement it, that's exactly how you do it. So you need hardware and software both knowledge, then only you go to the application. Same with the software-defined vehicle. If you're not able to collect the data from the sensors, आप cloud पे भेजोगे क्या? Forget how cloud system works. One student was asking how cloud works. It's not my job to find out how cloud works. वो तो cloud engineer का काम है. As an electrical mechanical engineer, my job is to give the data for the system to send it over the cloud. If you don't know how to integrate the sensors, if you don't know how to take the data, how to perform the processing, how to implement CAN communication, I2C, SPI, UART, USART, if you don't know this, तो आप SDV करोगे कैसे? You will never be able to do the SDV. At the practical level, you should know how to integrate your hardware. You should know how to program your microcontroller, your ECUs, right? Your BMS ECU, your charging ECU, your ADAS ECU. Every system has its own ECU. And then you will be able to combine it with the software. That is why before you go into SDV or ADAS, hardware and software, दोनों की knowledge is inevitable. It's very important. I will just wrap up here, guys. इससे ज़्यादा कोई मुझे पढ़ाता तो मैं भी नहीं समझ पाता. I think this is good enough for the webinar. I just wanted to explain you that how exactly you would be able to reach to this level from what you are doing right now. अभी आप जो कर रहे हो वहां से आप यहाँ पे जाओगे कैसे? This is the vision, this is the roadmap. And the next course which I am launching with you for you guys, जो मेरे students हैं यहाँ पे, is on the development of the communication system with the ARM Cortex. That how do you implement the CAN communication? How do you implement the the wireless communication? And then you will be able to send the data from the sensor to the ARM Cortex, and then you're ready. Then we will directly jump to the ADAS applications and the development part. And then once you're done with the ADAS, then you go with the AUTOSAR, because then we will show you the example that within ADAS, how do you implement the AUTOSAR? Because AUTOSAR का काम यही है. AUTOSAR does not mean that I change the system. AUTOSAR says there should be a different layer for every system. आगे चलकर आपके ADAS का कैमरा खराब हो गया, you should not be replacing the whole system. AUTOSAR will say just replace the hardware. I am taking care of the communication and the software part. And this is the importance of AUTOSAR. But वो तो तब आएगा ना once you have the whole system with you. That is why AUTOSAR is the last stuff you will do once you're done with all of this. And that's how the whole vision, that's how the whole flow of learning will go. Okay. Perfect. I think, Rahul, this should be all from my side, isn't it? I think should be enough for the students. Otherwise, students give thoda sa.
Yes, I guess, sir. Definitely.
Okay, so Tilak, you're saying AI sensor and AI screen also coming. Yes, Tilak, it is coming. See, at the industry level, things will keep on coming. But the point is that what do I need to do as a part of my ongoing expertise, ongoing technology trend? AI sensors, you might work with AI sensors maybe after 3 years, 4 years. But दो चीजें होती हैं guys. Either you learn something, you say, okay, I know that AI sensors are coming, AI sensors का ये architecture होता है, this is how it works. But if you don't know how to program your AI sensor, then it's not really relevant for you as an engineer. My recommendation would be stick to those technologies which you will be able to implement with me. You are very soon going to work on the application part. When your embedded and all will be done, only one more course is left, and then we are going to develop our own BMS. मैं बहुत टाइम से कह रहा हूँ, 2-3 महीने से कह रहा हूँ, right? Own BMS, own charging controller. We are very soon, in the next 2-3 weeks, we are going to start developing those things. So let's focus on those technologies which are possible for us as of now. AI sensor and all is perfectly fine, wonderful technology, but we don't really need this as of now at our level. बहुत ज़्यादा हाइपोथेटिकल डोमेन में चला जाएगा. But okay, it's a good point. AI sensors and all are good. Okay, how MATLAB is useful in mechanical department? I have just told you, right? The exact way how you will be implementing the ADAS. अगर आपने देखा है how to implement ADAS, you will know how MATLAB will be useful. If you don't know ADAS and these systems, you will not be able to work on the AUTOSAR also. Because AUTOSAR आया इसलिए that these kind of systems can be integrated in layers part. Problem क्या होने लग गई थी कि अगर एक हार्डवेयर खराब हो रहा था, पूरा सिस्टम खराब हो रहा था. So AUTOSAR said, let's redistribute the system in layers. Basic software layer, application layer, hardware layer. अगर कोई सॉफ्टवेयर में प्रॉब्लम है, just replace the software. हार्डवेयर और एप्लीकेशन लेयर को मत छेड़. ADAS and all are all the application layers. Basic software is जो आप बना रहे हो अभी, जो बनाओगे, where you are developing these embedded algorithms. This is the basic software. How to apply the brakes, how to check the sensor data. All these are basic software. Hardware layer is where you have the sensors, microcontrollers and all that. Actually, MATLAB is very useful in the mechanical department. अगर आपने देखा है ADAS का implementation, all you'll understand, right? See, it does not depend, Satyam, कि automotive landscape SDV framework में कैसे change करेगा India. This is something which is happening at the global level. Okay? When I say at the global level, companies are already coming with the SDV frameworks. Whenever you start your vehicle, many of the vehicle models are sending the data over the cloud. हमें नहीं पता चलता, but vehicles ये चीज कर रहे हैं. So this is something which is widely accepted. There is nothing really which Indian government is doing specifically to work on a SDV. This is more at the global technology level. That is the main reason why we find Tesla as the best of vehicle, because it is smart vehicle. It is using this SDV drastically in a very intensive manner, right? And okay, just a second. In what ways machine learning being integrated into ADAS? I'm just going through the questions. अगर आपका question miss हो रहा है, just give me on chat. See, once you are able to take the data, Satya, एक बार हमने data ले लिया, okay, from the sensors, you will be able to find out whether there is a problem in your vehicle or not. I'll give you a very basic example. Let's say you are taking the data for your battery voltage, battery current, battery power. You are calculating the SOC, SOH, SOP, everything. Using machine learning, you can tell them at the later stage that with this SOC trend, your battery is going to fail in the next, let's say, 17 hours. As I said, ये बहुत बात की चीज है. हमें चाहिए क्या पहले? We need to be good enough to collect this data, right? We need to be good enough to collect this data We need to be good enough to create the data set. Without data, we cannot do any machine learning. With data, we can implement anything you want in the world with machine learning and AI. So that is why मैं सबसे हमेशा स्टूडेंट से बोलता हूँ that is the main responsibility. जो अभी आशुतोष की वर्कशॉप भी हुई थी उसमें क्या था? We started with very basic how do you take different kind of data set, how do you program the AUTOSAR and all. The next workshop will be focused entirely on different sensors. कि आप सेंसर से डेटा ले कैसे रहे हो and how you are sending it to the controller using the CAN. This is exactly the basis of the AUTOSAR. How do you implement the CAN communication? We call it the RTE, the real-time environment, where you communicate the data from one controller to the other controller. Once you have the data, Satyam, फिर machine learning लगाओ, AI लगाओ, does not matter. But you need to have data, real-time data. As an engineer, this is the most important thing. Okay. EV AI courses tilak would be too much to cover. Trust me, EV AI courses का use ही नहीं होगा. It's more at the research level right now. Even if I teach you AI, EVI, I'm currently using AI for my physics now. You know, I'm working as a scientist in Germany and also I'm using this AI for the physics part. But it is more at the research level. If you learn something, for example, मैं आपको quantum computing सिखा दूँ. Quantum computers are like one of the biggest, technology shift we are going to have. But right now it is more at the research level, even at the industries. Gradually it will move towards the commercialization part. जब उसका commercialization ही नहीं है तिलक तो EV AI पे हमें क्यों ही जाना भी? First we need to make our EVs good enough to have real-time analysis. That is the main thing, guys. Perform data analytics before you go to data science. Data science बहुत easy होता है. Data analytics is more difficult part. That is only possible when you are able to collect the data from your hardware system, the real-time analysis. Okay. Okay, what is the current limitation? It depends. It depends, Satyam. What is your application? If your ADAS is not good enough to detect the signal because the signal level is very poor, it is one of the limitations of your ADAS. It also depends on the sensor you're using. It also depends how fast your microcontroller is working, right? What is the baud rate? How fast you'll be able to work on your microcontroller. अगर आपका controller इतना speed में work ही नहीं कर रहा कि वो signals को properly ले पाए, naturally your ADAS will be slow in responding, right? Okay. While integrating our hardware and software, what are the key things we need to keep in mind? That you need to be good with software and hardware both, Aditya. Because the problem is now you will never be able to integrate your hardware and software if you don't develop your own hardware and if you don't develop your own software. ये बहुत मुश्किल चीज़ है. Trust me, very few people will be able to do it right now. We are actually trying to do something difficult here. Because ये इतना ज़्यादा आसान काम नहीं है where you are developing your own hardware algorithms, you are developing your software simulations also and then you are combining. You have to go step by step. अगर आप बिना embedded C सीखे, अगर आप बिना basics of ARM Cortex सीखे directly sensor पे jump कर जाओगे, you will never be able to work on the hardware, the actual hardware. फिर वही चीज़ हो जाएगी, बच्चे बोलते हैं कि सर आई नो AI, मैंने AI का मॉडल पिक किया और उसको रन कर दिया. But that's not AI. You are just working as a plug and play. But we want कि भाई at the end of the day you should be able to program your sensors, the hardware, and should be able to build your software from scratch. This is actually not easy, but once you're able to do it, you build the actual application, right? Satyam, as a mechanical engineer, जो मैं बता रहा हूँ उसी को follow करो. Trust me. Make your MATLAB very strong because now we are entering into the ADAS part. तभी हमारे webinars भी अब ज़्यादातर ADAS और SDV पर हो रहे हैं. Because my courses are almost ready to make your transition into the ADAS. At the same time, if embedded thing is done, we are launching this embedded advance, and then you go to the CAN communication, sensor interfacing. Just follow this trend. अगर आपने embedded भी अच्छे से कर लिया ना for EVs, it is good enough. अगर आपने MATLAB भी अच्छे से कर लिया, it is good enough. We are going one step beyond. We are trying to go to one step beyond, where we say you're developing the SDV application, you're developing the ADAS application. आप इतना भी इनफ पढ़ लोगे तो बहुत है. How many students know both embedded and MATLAB at the same time? I think 1000 में से एक बच्चे को आता होगा, right? And Ram, once you have the data, that's exactly how data analytics will work. But बच्चे analytics perform क्यों नहीं कर पाते? Because उनको real time पे पता नहीं होता. They don't really know how do I collect the data, how do I perform the analysis, how do I integrate the sensors, where do I store the data, मैं data management कैसे करूँगा, उसके बाद कहीं जाके मैं cloud पे भेजूँगा, right? So once you have the data, you can perform the analytics within your microcontroller or within your Python based controller, or you can send the data over the cloud. फिर वो आपके ऊपर है. बट यू नीड टू गेट दैट डेटा जहाँ पर आपको हर सेकंड सेंसर से डेटा मिल रही है, 5 डिफरेंट सेंसर्स, डेटा दिए जा रहा है, आपका प्रोसेसर आर्म कॉर्टेक्स, इट इज मेकिंग योर डेटा इन अ प्रोसेस्ड वे एंड यू आर गेटिंग एन एक्सेल शीट after every 1 hour, 2 hours. This is exactly what you would need to do, right? Don't go for autonomous vehicle, Arvindan, directly. Okay. If you don't know anything about coding, you have to first be very good with embedded C. So you cannot go to autonomous vehicles. See, there are two ways to go to autonomous vehicle. Either through the software part only, जहाँ पे Python वगैरह यूज होता है, और through the hardware part as an engineer. If you want to work it as an engineering level, naturally you need to work on this embedded programming languages. This is very important. And then you can gradually move into the basic operations. For example, automatic brake लगाना. मैंने एक सेंसर ले लिया, अल्ट्रासाउंड, मैंने हाथ लिया सामने, उसने ब्रेक लगा दिया. सुनने में बहुत आसान लग रहा है, but when you do it with MATLAB, actual camera, ARM Cortex, it actually become difficult. अभी किसी ने बोला कि सर आर्डिनो से बेटर क्यों है? बिकॉज आर्डिनो कोई इंडस्ट्री यूज ही नहीं करती कभी लाइफ में. ओके, आर्डिनो कोई इंडस्ट्री यूज नहीं करती. आर्म कॉर्टेक्स समथिंग एवरी इंडस्ट्री वर्क्स. इट्स वन ऑफ द मोस्ट सोफिस्टिकेटेड कंट्रोलर्स. वी शुड बी एबल टू यूज इंडस्ट्री लेवल कंट्रोलर्स, इंडस्ट्री स्टैंडर्ड कंट्रोलर्स, सॉफ्टवेयर, हार्डवेयर सिस्टम्स. देन इफ यू इम्प्लीमेंट दिस बेसिक टूल ऑल्सो ना, दैट आई हैव दिस अल्ट्रासाउंड सेंसर, मैंने हाथ डाला, मुझे ब्रेक लग गया, मुझे दिख रहा है कि मेरी चार्जिंग रुक गई है, because I have this charging control algorithm. When you connect the dots, it will happen gradually. अब एकदम से autonomous में नहीं जा सकते. You first need to make a circuit जो आपका बैटरी रोक दे. For example, अचानक से गाड़ी क्रैश हो गई. You should immediately cut the connection with the battery. You should know how to control my controller कि वो बैटरी का कनेक्शन एकदम से रोक दे. Right? So yeah, that's how it is. Tilak, this is a recorded webinar. I guarantee if you are able to work on this embedded thing, software thing, अगर आप ADAS तक नहीं भी जाओगे ना, it's more than enough. Because we are actually focusing on the main applications now. ऐसा नहीं है कि मैं आपको Arduino पे पढ़ा के छोड़ दे रहा हूँ. Arduino मत पढ़ो जिंदगी में कभी. We don't need it. Focus on core part. And अगर आपको डाउट हो रहा है, just go to internet and say embedded system job, embedded engineer job, HIL job, SIL job. You will find at least 5,000 jobs right now in your own state. Forget country. So you do it, you go it and you search it. So ADAS तो बहुत बाद में आएगा. अगर हम यही चीज़ implement कर लेंगे ना, ANSYS, MATLAB, embedded, these are the applications of technology, right? Just go for the internet and search कितनी jobs है हमारे पास. I2C, UART, UPSART, STM32. That's how exactly how we build the EV. वरना EV build ही कैसे करेंगे? वही हार्डवेयर के ऊपर हम लोग फिर स्पॉट वेल्डिंग करते रहेंगे. That's not really relevant at the engineering level. Well, you don't need to use MATLAB for free, guys. अगर आपको MATLAB नहीं मिल पा रहा, आप मेरे से सॉफ्टवेयर वर्जन ले सकते हो. If you don't want to use the crack and all, I can get connected with the MathWorks. We have a collaboration with MathWorks. Then you can of course use MATLAB. No issues at all. Okay. Satyam, you don't need to go with open source project. We will cover the AUTOSAR and ADAS. Don't worry at all. But जैसे मैं बार बार बोल रहा हूँ, if you don't know how to work on the embedded part, वो सिर्फ theoretical level पे रहेगा. Okay, we have the ADAS and AUTOSAR course coming with the MATLAB only. But at the end of the day, embedded भी बहुत inevitable है. Without HIL, SIL की value कम हो जाती है. That's the final journey. अपने कोर्सेज अपडेटेड रखो. जस्ट कवर दीज बेसिक कोर्सेज जो होता है ना, एडवांस BMS, चार्जिंग वगैरह, एडवांस मॉडलिंग यूजिंग MATLAB. जस्ट फिनिश दीज कोर्सेज सो दैट यू कैन स्ट्रेट अवे फोकस ऑन द एप्लीकेशन पार्ट. दैट्स द मेन थिंग. ओके, चलो काफी देर से. ओके, नाउ लेट्स गो टू द वेबिनार चैट क्वेश्चंस. आई थिंक राम, ये सेम क्वेश्चन मैंने भी बताया, राइट? एनालिटिक्स, आई अवॉइड दिस क्वेश्चन नाउ. Okay, this is also covered. Why ARM Cortex भी बताया प्रताप, right? Because Arduino है ही नहीं industry level पे. It is only for students to learn. It works for the Atmega. I think Atmega 32 microcontroller पे work करता है Arduino. कहीं use नहीं होता. Okay, so that's not at all relevant for us. ARM Cortex is something. आगे चलकर अगर आपने कभी pure electronics वगैरह पे काम किया, you will work only on ARM Cortex basis or maybe something similar version to in these ARM Cortex based. So I want you to basically, ये मुश्किल है ARM Cortex. Arduino programming बहुत simple है. It will hardly take 5 hours to connect a sensor with Arduino. वहीं पे आपको ARM Cortex में एक सेंसर कनेक्ट करने के लिए कम से कम 15 से 20 दिन का एक्सटेंसिव कोर्स करना पड़ जाएगा. Because that's the actual programming. That's the actual hardware assembly programming, right? We need to work on that. If you're interested in camera-based autonomous feature, how I can learn to get a job related to IT? Well, to get a job related to IT, you need to work on the cloud-based data analysis. अगर ये IT नहीं लिखा है, अगर ये IT लिखा है सिर्फ, then you need to see how do you integrate your camera. See, there are two ways. आप कैमरा डायरेक्ट लैपटॉप से कनेक्ट कर लो and you get the data to the MATLAB and MATLAB पे अपने एप्लीकेशन बिल्ड कर दो. This is also good. Absolutely good. This is exactly what we will do in the ADAS course. Once you have the data from the camera coming through your embedded, then it becomes the HIL. So at the SIL level, guys, वो फिर भी easy होगा. That you're connecting your webcam directly to your laptop. Laptop के अंदर तो पहले से embedded डला हुआ है ना. You don't have to develop the embedded. Laptop के अंदर पहले से ही chip है. It is giving the data to the MATLAB. So that is already easier. So you can do that at the SIL level. SIL level it becomes easier. Then the main story is when you connect it through your embedded. But yes, you can do it at the software level also. Okay. नहीं ऐसा नहीं है प्रताप. If you go with low cost outboard charger, Arduino is preferred because Arduino प्रताप is very good for your own learning. I'm not saying Arduino अच्छा नहीं है. I'm just saying Arduino works for the Atmega 32 controller. Atmega 32 में ना cache memory है. The baud rate is very slow. The RAM in the chip is very low. It will not be able to save too much data. आप उसमें data management कर ही नहीं सकते. It will be much slower as in order to perform the complex algorithms. Industries will not perform. It's not problem उसके controller में है. The Atmega controller we are using. You replace Atmega controller with some different controller system, then surely you can use Arduino. It depends. At the industry level, Arduino के बहुत सारे limitations आ जाते हैं प्रताप. Specifically, if you want to implement some real-time processing, आप basically आप multi-threading नहीं कर सकते. You will not be able to perform multi-operation, multitasking because the controller is not capable of doing that. It's more about the controller. Arduino एक development board है, which is including everything together. उसके साथ उन्हें switch भी दे रखा है, resistances, capacitors and all. It's a development board. Similarly, STM32 is a development board. You have to focus more on the controller part. Okay. पीयूष इसका बहुत अच्छा आंसर भी दिया ना. Which interdisciplinary skills you need? You need to use one good software like MATLAB where you implement all of this at the SIL level. If you want to go one step beyond, you work on the embedded and the hardware for the HIL. That's how you combine the ADAS and the SDV. Once you know how to take the data, फिर उसके बाद it depends. You need to work on data analysis and all, but वो बहुत बात की बात है. We don't need to go that much. ऐसा भी नहीं है कि हमें पूरी जिंदगी बस पढ़ते ही रहना है. That we can do once we go at the industry level also. Okay, perfect. So I think this should be all right. काफी लंबा session था. It's almost 2 hours. I hope the session was good. I'm happy I was able to interact with you all. So मैं बस आपको vision दिखाना चाह रहा था guys. Constantly मैं इस पे काम करने का try कर रहा हूँ. And that's exactly what we want to do at the end, build the applications. But ये बहुत लंबी जर्नी है. Industries को भी time लगता है इसमें. So naturally as student you also need to give time. It's just that how fast you do it, right? And embedded खुद में एक बहुत बड़ा domain है. MATLAB खुद में एक बहुत बड़ा domain है. Don't feel overwhelmed with this. ऐसा मत सोचो कि बहुत सारी चीजें एक साथ आ गई. Just work one by one and you will see कि gradually हम लोग application develop कर पा रहे हैं. Once you have your own CAN protocol and all, you will see कि ये चीजें चल रही हैं. You will realize that the magic is happening actually. Okay, चलो perfect then. ठीक है, then we can wrap up the session, guys. Thank you for your time, and I hope it was a good session. Wonderful talk by Rahul, no doubt, and we can connect again for the upcoming webinar. I think this weekend we have a webinar on power electronics. So if you are slightly more into this electronic systems and circuit design and PCB and all, you should surely be a part of it. इस type के sessions ना webinar guys courses नहीं होते. They are like to give you the idea what you can do as an individual. So these kind of sessions are actually built specifically in a different way so that we can try to show you कि क्या कर सकते हैं हम, what you can do, but सिर्फ theory level पर नहीं, at the implementation level. Okay. Chalo, perfect then. Thank you for your time, guys. I am wrapping up this session. I think I am just leaving the session now. I and DIYguru can close this session if they want. Thank you, guys.
Thank you, guys. See you at the next webinar. Thank you.
I think the certification link you will get based on your email ID and response. Okay, should not be a problem then. Okay.
Thank you, sir. Thank you so much. Thank you all for joining in. Have a good night.